Welcome to our series of short educational videos which describe important concepts of building performance. And this video discusses the following: what is thermal comfort and what parameters are used to describe thermal comfort. Let's just go through what actually is thermal comfort, or at least how do we understand it. The first one is that thermal comfort is a very personal experience and expresses the personal satisfaction with the thermal environment. The second one is somewhat a derivative of that, because it says it's a very subjective experience, thermal comfort. So if one person is satisfied with thermal comfort, another might not be. Then in hot climate, as in Hawaii, the human body generates excess heat that has to be rejected to the environment. And the last one is what we use here: the more heat the human body generates, the more heat must be rejected to the environment. This means that we have to be very effective in terms of heat loss to maintain thermal neutrality. There's a combination of indoor thermal factors which actually create the thermal environment which will be acceptable to a majority of the occupants. And here the important thing is the majority of the occupants, because not everybody has to be in this space satisfied so that we can state that there's good thermal comfort in the space. So the thermal factors which we are referring to are divided in two categories. One is the environmental factor, which is factors representing the indoor conditions. This means if we have multiple people inside of an internal space, these environmental factors apply to all of them. The next one would be individual factors, and these are factors that represent and are under the control of the occupant. This also includes the activity, metabolic rate, and clothing insulation. So these 6 factors are actually which determine the comfort level are described as follows. We have two categories, as we said. The one actually is the individual conditions, individual thermal condition, and then we have 2 factors in there. One is the clothing and one is the metabolic rate. Metabolic rate tells us how much heat is created and has to be rejected, and the clothing is how much insulation is actually on the human body. I mean, the most effective body condition would be like a nude body that can get rid of the most heat. But of course, we cannot have that usually, and so we have to have clothing, and the clothing is some kind of an insulation. The next one would be the 4 thermal conditions which are representing the indoor space, which is the air temperature, the mean radiant temperature, which signifies the radiant heat loss. The humidity means how much water vapor is in the air, and air velocity. Let's go through all of them. The first one is the individual thermal condition, and here we have the metabolic rate, and it's defined as the rate of transformation of chemical energy into heat and mechanical work by metabolic activities of the individual. And the chemical energy is coming from the food we are eating. So whenever we need food, otherwise we couldn't actually perform and live, of course. So, and the heat and mechanical, the heat which is produced by metabolic depends on the level of activity, which we see in the lower diagram. And we also have an expression, a quantifiable expression here, which is the metric. And it's like some numbers here, but basically it tells us what kind of heat output per unit skin surface. And so the heat energy produced per unit skin surface of an average person seated at rest. So this is actually 1 met. And and a person usually has about 1.8 square feet of skin. The next individual thermal condition is clothing insulation, and we told that already. Thermal insulation provided by garments and clothing. So that means if we have clothing on our skin, it acts like an insulation. So it holds back the bodily heat at the body, and is in the way of just being, rejected to the environment. And the metric is CLO, CLO, and also has a certain, numeric value which we can read here. So, and we can determine the CLO and by adding up all the different clothing we have, on our skin, and we add all these CLO factors of the different garments or clothing, and we come to a total CLO value. So a shirt, a pants, underwear, socks, shoes in our case, they all have individual CLO factor. We add it all up and we get the total CLO value, which we then use to define the thermal comfort. Now we go to the thermal condition representing the indoor space, and we have air temperature, which is very intuitive. That's the temperature of the air inside of the indoor space, and it's determined by the dry bulb temperature, either in Fahrenheit or Celsius. The next one is a little bit more complicated. It's the mean radiant temperature. And the mean radiant temperature is an approximation and really helps us very much to define, the radiant heat transfer processes in the room. Because the mean radiant temperature is actually a single value temperature of a uniform black enclosure that exchanges the same amount of heat by radiation with the occupant as the actual enclosure. That's some kind of a wording here. But basically it means you see a globe thermometer on the left side, which is like a little, it's a globe, of course, therefore it's called globe thermometer. It's like a little ball painted in black, and inside is a thermometer which measures the air temperature inside of the globe. So all these different radiant components impinging on the surface of the globe thermometer, and they actually help heat up the temperature of the air. They heat up the air inside of that globe, and this can be measured. And it is very useful as an approximation. As we see on the left side, the actual room, we have the person there, and the person experiences radiant heat transfer for all kinds of different components inside of that room. So to be correct, we would have to add everything up in terms of how big is the surface, what is the temperature of the surface, and add it all up, and it can be very cumbersome, and it takes a lot of time. So we help us of sticking like the globe thermometer, let's say at the place of the person's head or the shoulder. This is actually the location of concern, and we measure then what we call the mean radiant temperature, and we take it as an approximation of the real radiant condition of the room. So mean radiant temperature is very helpful. So we have air temperature and mean radiant temperature, and right now we get an expression which is also very useful, and it's called operative temperature, and it is the resulting and representative temperature as a combination of air temperature and mean radiant temperature. And there's several definitions depending on how much air is flowing and all kinds of stuff, but we want to take only the typical average, the typical value here, and the typical is like average of air and mean radiant temperature, which is air temperature plus mean radiant temperature divided by 2 equals operative temperature. Again, this is the simple average of these two temperature, air and mean radiant temperature. Operative temperature, we'll see this later on, very helpful. The next condition here is airspeed, and we say the average rate of air movement at a point without regard of direction. So it only signifies the velocity of air which goes over our body, and we really don't care if it's going from right or left to right. It only is the cooling effect increases with the speed of air going past our body. And the metric here, which is usually used as foot per minute. The next thermal condition here is relative humidity, and I think everybody knows this, and this is the ratio of humidity level in the air to the humidity level in the air at the equilibrium. And this is a thermodynamic equilibrium. So we can go actually into the very precise definition. Would be like an actual partial pressure of water vapor to equilibrium vapor pressure of water at a given temperature. But right now, for us, it suffices of saying relative humidity can be measured and is given us as a percentage. So right now we have these 6 conditions and factors. And what are we doing with this? So they're very helpful of saying, all right, this defines the thermal comfort, but we would like also to quantify it. We would like to say, hey, the thermal comfort has a certain quantity, a certain value. And this one we can use with the help of the ASHRAE 55 standard, and it's called Thermal Environmental Condition for Human Occupancy. And we will be discussing these ASHRAE 55 briefly in one of our next videos. So this one brings us to the end, and we again have a self-learning assessment, and let's see how much you remember. And we would really invite you to do this little exercise. First of all, ask yourself, or you can also discuss it with your friends and colleagues, why does the human body have to lose or reject heat to stay functional and healthy? The second one, you remember we had 6 thermal conditions. The first 2 are individual. And what are these 2 individual conditions which describe thermal comfort? And the next one is what are the 4 thermal conditions representing the indoor space? And the last one, what standard is used to describe thermal comfort? So thank you very much, and again we invite you to go through the self-learning assessment. It really will help you to learn and to understand and to remember all these things which are important. Again, this brings us to the end. We thank you very much for your interest, and we would like to join you. Please join us again for one of our future short educational video in our series.